Okay, guys, we're going to attempt to do 4 pages of notes today in my absence, and it's actually one of the most interesting things that we've done so far with vectors. Everything's been kind of elementary. This is a little bit more advanced, however, it's very, very straightforward, and typically people do very well in this portion of the test, so I totally think you can pull it off. And so you see a lot of things here. We're going to be talking about scalar products and vector products of two vectors. The only one you're going to be responsible for is called a scalar dot product. Okay, so what I'm going to do is I'm going to give you two vectors. I'm going to give you vector v is 1, 2, 3. And I'm going to give you vector w, which is 1, negative 2, 4. And what we're going to do is find what's called the dot product. So this is going to be v dot w. Okay? And the way that you do a dot product is you multiply the x's plus multiply the y's plus multiply the z's. And that's it. Okay? So if you see, this is the formula up here for a dot product. They're saying v1 times w1. Okay, so they're multiplying the x's plus v2 times w2 plus v3 times w3. So that's all we're going to have to do a dot product. So multiply your x's, 1 times 1, plus multiply your y's, 2 times negative 2, plus multiply your z's, 3 times negative 4. Excuse me, 3 times positive 4. Okay, so then I just have 1 minus 4 plus 12, or 9. Okay. Now, if you think about this, I multiplied two vectors. Vectors have both magnitude and direction, but I ended up with a quantity that is scalar. 9 does not have any direction to it, okay, but it is actually a scalar answer. Okay, dot products are the only kind of product that you have to know for the IB exam. Okay, there is, just so you know, something else called a cross product, V cross W, and that would actually yield a vector answer. But this is not covered in our syllabus. Okay, but just in case you run into that in college, you'll know that there are two different kinds of products. Now, how this is going to be useful for us, the most common application is we're going to be finding the angle between two vectors. So here you see a vector v drawn, and coming from the same point, emanating from the same point, a vector w. And what they're going to want us to do is find the angle between these two vectors. Okay, and the way we find it actually comes from the law of cosines. Okay, so remember back, you have the law of cosines because we have a nice little triangle there. Okay, so the law of cosines looks like c squared equals a squared plus b squared minus 2ab cosine c. Okay, and really you're just going to be looking at these as three sides of a triangle. So you have v and w emanating from the same point. So this guy over here, if you think about how can I make this vector, okay, so let's see what we could do. If we started here and wanted to go to here, okay, we would go the opposite of v plus w. Okay, so that's the opposite of v plus w. Okay, and so the length of this guy right here, the length of this guy, okay, so this is w minus v, or negative v plus w, whichever way you want to look at it, because we got there opposite of this way plus this way. Okay, and so you're just going to be looking at it as three sides. The length of each side would be indicated by the magnitude. So this would be like the magnitude of w, the magnitude of v, and the magnitude of w minus v. So you can actually take and prove, and I'm not going to do that to you. It's not a proof that's the favorite of students in the past, but you can take that from the law of cosines and develop a formula for finding the cosine of your angle. Okay, and what this will end up looking like is the cosine of your angle will be equal to the dot product of the two vectors divided by the magnitude of each vector multiplied together. Okay, And so, and just remember, it comes from the law of cosines. This formula is on your formula sheet, and it's going to enable us to find the angle between two vectors. Okay? All right. So we're going to move on to the next page. There's a lot of questions on this page, but I'm going to demonstrate them through problems. Okay? So let's take a look at this. This is going to be the same thing as what we just did. We have a vector P and a vector Q. Remember, they're using bold. And when I write it, I'm going to use arrows. So the first thing they want is the dot product. Okay, so when you see this guy, this is P dot Q. So what we're going to do is just multiply our x's, so 2 times negative 1, plus multiply my y's, 3 times 0, plus multiply my z's, negative 1 times 2. Okay, and so when we do that, we're just going to have negative 2 plus 0 minus 2. So we have a dot product of negative 4. So that's the first thing they asked me for. Now the next thing they want is the angle between P and Q. Now we know it's not particularly a lot of fun to draw points 3D, so I'm just going to kind of give you the idea. We have vector P, we have vector Q, and our job is to find this angle in between them. Okay, and we're going to do that using the formula I just gave you. Okay, so cosine of that angle will be equal to the dot product over multiply the magnitude of each vector times each other. Okay. Now normally I'd have to take a minute and find the dot product, but they asked me to do that in the first part. Okay, so if we didn't already have that, we would just put that in right here. Multiply your x's plus multiply your y's plus multiply your z's. Now this is the magnitude. Remember, the magnitude just looks like your Pythagorean. So this would be the square root of, and for the magnitude of P, you just do the square root of 2 squared plus 3 squared plus negative 1 squared. Okay, so this is 2 squared plus 3 squared plus negative 1 squared. Okay, so all of that is just the magnitude of V. Okay, so this part is this part. Okay, and I need to multiply by the magnitude of W. So same thing, to figure out how long W is, oh sorry, I mean these are P and Q, but it's the same thing. It's just these are the letters they use on your formula sheet. Okay, so I'm going to do the same thing with Q over here. Square root of negative 1 squared plus 0 squared plus 2 squared. Okay, so you see then that this little guy right here is this part. Okay, that's telling you how long W, that vector W is. So really, I just need to simplify this, okay? Because then I'll know what the cosine of theta is. Then I can just do the inverse cosine, and I've got the angle. Okay, so let's see what I can do here. I've got negative 4 over square root of 4 plus 9 plus 1. And this one is just 1 plus 0 plus 4. So I've got negative 4 over square root of 14 times the square root of 5. Okay, I can combine those if I want to. Okay, so that would just be the square root of 70. Alright, so now what I know is that the cosine of my angle is equal to negative 4 over 70. Kind of running out of room, so I'm going to go up here. So if I know the cosine of theta is equal to negative 4 over the square root of 70, then my angle is equal to the inverse cosine of negative 4 over the square root of 70. And you just want to put that on your calculator. We're dealing with vectors. We tend to deal with degrees. Okay, so when you do this on your calculator, let's get in degree mode. Okay, so go to a nice fresh calculator page. I'm going to go up here and check. And up, it looks like I'm in radians, so I'm going to click on that guy. Go to my document settings, tab, change this to degrees. Everything else is awesome. All right, just going to double check. I always like to. Yep, we're good. Okay, So now we're just going to go to our trig functions, and there's our inverse cosine. Sorry about that. So we have inverse cosine. Click on that. Control divided by, and then we've got negative 4 over square root of 70. Okay, so hit enter. And there we have what that angle would be between them. So it's 100, about 118. Remember, we only have to show 119 degrees if we only show 3 digits. And so that's how you find the angle between two vectors. Okay. Now, one of the other things that they're going to want us to think about, one of their favorite things to do, is for us to figure out when two vectors would be perpendicular. Okay, so we're going to have to think about this a little bit. For perpendicular, okay, another word for perpendicular when you're talking about vectors is orthogonal. Okay, so orthogonal is the same as perpendicular. So if we think about our formula, cosine theta, and you don't have to write the formula again, okay, it's just helpful to me here. We want to think about, well, when would cosine be equal, when would the angle be 90? Okay, what would be going on there? So let's think about if it was orthogonal or perpendicular, then it would turn out that the angle would be 90 degrees. Okay, so what if we put in cosine of 90 degrees here? All right, we took a look at that. Okay, so let's think about what the cosine of 90 is. Well, the cosine of 90 degrees is 0. Okay, so this would have to be 0 for this to work. Now we know we can't have division by 0, so that's not too much of a problem because we wouldn't want vectors of length 0 anyways, okay? And then we wouldn't be talking about an angle between them because it wouldn't exist. It'd be just a 0 vector. So in order for this to be 0, the numerator is going to have to be 0. And that's going to be a little trick that they use a lot, okay? And that's going to be that you're going to know if two vectors are orthogonal or perpendicular, their dot product is going to be 0. Okay, and that's true for orthogonal. Okay, and that's going to come in handy a lot. Okay, another thing they do a little bit is talk about parallel vectors. Okay, so we figured out everything about orthogonal. For parallel, let's look at what the difference would be. So I'm just going to go up here. They do not really tend to ask you about this as much, but if you think about two vectors being parallel, they could be going in the exact same direction. Okay, and so then the angle between them would be 0 degrees. Okay, the other thing that could happen is they could be going just the same way, only opposite directions. Okay, and then it would be 180 degrees. So that would be what was true for parallel. So if you think about that, let's think about what the cosine of 0 would be. Okay, the cosine of 0 is 1. And if we think about the cosine of 180 degrees, okay, that's actually negative 1. All right, so I'm just going to look at what would happen in our formula there. So if we had cosine theta equals V dot W over the magnitude of these guys, okay, if it was 0 degrees, this would turn into 1. Okay, and so we couldn't really conclude anything about the dot product, but if we multiply both sides by the denominator, okay, what we know is just that the dot product would have to be equal to the product of the magnitudes. Okay, and then it would be almost the same if you had negative 1 right here. You would just have a negative sign here. Okay, so what happens is if they're parallel, you see what they have right here, that the dot product would either have to be equal to multiplying these two together, multiplying the two magnitudes together, okay, or it would have to be equal to the opposite of that, either one. Again, the parallel does not come up a lot, but the orthogonal or perpendicular comes up all the time. You have to know that the dot product equals 0 if they are perpendicular.